Hello everyone. Now we'll be doing manufacturing problem, which is a part of linear programming problem. I have picked out this question myself, so I'll be explaining it and then formulating it. The solving part you will be able to do if you watch my previous videos. So in that I have clearly explained how you can solve these kind of problems. So let's start the problem and go through the problem 2 or 3 times. It says a manufacturer produces 2 products A and B. Both the products are produced on 2 different machines. The available capacity of first machine is 12 hours and that of the second machine is 9 hours. Each unit of product A requires 3 hours of both machines. That means machine 1 and first machine and the second machine. It requires 3 hours of both the machine. And each unit of product B requires 2 hours of first machine and 1 hour of second machine. Each unit of product A contributes 5 to profit, rupees 5 to profit. That means if I sell 1 unit of product A, I will get 5 rupees profit, and if I sell product B 1 unit, I will get 6 rupees profit. So formulate and maximize the profit. So we need to maximize the profit. Okay, now we need to draw the first understand and then draw the table for this. Okay, here I have drawn 2 machines, machine 1 and machine 2. Okay, machine 1 every day it will work 12 hours and machine 2 every day it will work 9 hours. Understand this. Okay, now don't write this one, don't understand this one. Okay, now product A, it has to go from machine 1 for 3 hours. It has to be processed by machine 1 for 3 hours, and the product A has to go through machine 2 for 3 hours to become a product. Similarly, this product B, it needs 2 hours of machine 1 and 1 hour of machine 2. That means, suppose this is my product. This, to get finished, it has to go from machine 1 first. It will go from machine 1 first. For 3 hours it will be here, and then for 3 hours it will be here for product A. So out of 12 hours, 3 hours is done, so 9 hours is left. So again another unit will come of A or B, we don't know. So similarly that time will be spent on each product. So we have limitation on machine 1 and machine 2 because they can work for only 12 and 9 hours. So that is the limitation for machine 1 and machine 2. So that 2 limitations we have. Now if you see the question, it says we have 2 products A and B. Okay, and then those 2 products will go from machine 1 and machine 2 to become a product. So you see product A goes 3 hours from machine 1 and machine 2 also it goes for 3 hours. Understand? Then product B goes for 2 hours in machine 1 and 1 hour in machine 2. So for this to become a product, it has to spend 3 hours in machine 1 and 3 hours in machine 2. For this to become a product, it has to spend 2 hours in machine 1 and 1 hour in machine 2. Now profit in A, product A I will get 5, profit in B I will get. Now the limitation is on machine 1. See, it's 12 hours it can work, and machine 2 can work for 9 hours. Now looking at the table, you can see I'm producing, so I will produce some unit of product A and some unit of product B. So see, let the number of unit of product A produced be X units, and the number of units of product B produced is Y units. So according to the question, I have to maximize the profit. So the profit I'm getting from A is 5, and how much I'm producing? X unit. So if I'm producing 1 unit, my profit will be 5, 2 units 10, 3 units 15. So X unit will be 5x will be my profit. Similarly, I'm producing B. If I produce 1 unit, profit will be 6, 2 units 12, 3 units 18, y units it will be y. So we need to maximize this. Subject to what? Subject to what? Subject to what? See, the limitation is on machine 1. Machine 1 can work how much time? These two, machine 1 is working on this product as well as this product. Total it can work for 12 hours. So if I'm producing x unit of product A, 3 hours into x, so 3 hours into x plus, so y unit, so this should be 2y. 2y because machine 1 can work on A, that is x units, with 3 hour each unit, then with B 2 hour each unit. So altogether I can spend 12 hours, not more than that. So that's why less than equals to 12. Now machine 2 will work 3 hours. Machine 2 will work 3 hours. 3 hours for product A and 1 hour for product B. So total it can work for 9 hours, less than 9. Now x, the produce should be greater than or equals to 0. Okay, product A, the production of product A can be greater than or equals to 0. For product Y, it can be equal to or greater than 0. For the first equation, you can write it like this also with cancelling 3. Okay, while solving the problem, first draw this table, then you start with this. Okay, I hope you understood. Thank you.